Hello, everyone. It's good to see you. Welcome to the CIAT Speaker Series organized by the CIAT Graduate Research Colloquium. My name is Lee Hennessy. I'm an associate professor here at the School of Interactive Arts and Technology, and I've been helping to organize this speaker series this semester. We're very, very happy to be welcoming John Corbett, who is the newest member of the CIAT faculty, to present his work today in the Graduate Research Speaker Series. I just want to begin by doing a short acknowledgement of territory that Simon Fraser University is on the unceded ancestral territory of the Musqueam, Squamish, and Tsleil-Waututh peoples. And here in Surrey, we are in our campus are located on the overlapping ancestral traditional territories of the Katzie, Kwantlen, Coquitlam, Kwakwat, Tsawwassen, and numerous Stolo nations and the Coquitlam Nation as well. So this is important for us to be considering, and especially John's talk today is going to give us even more ways of coming to an understanding of what this might mean for us today in our work. Before we begin though, I want to invite Cynthia Tsui, who is a graduate student here at CIAT, who's going to introduce John. So thank you so much, Cynthia.
Okay, hi everyone. I hope everyone had a good reading experience. My name is Cynthia, and it's my pleasure to introduce John Corbett today, who is the faculty member at CIAT as today's speaker. So a little bit about John is that he is a member of the Métis Nation of Alberta, and he's also the creator of the Achimo programming language, also known as C# for the Nehiyah St. Cree Nation, as well as a specialized app, keyboard, and framework to program computers using Indigenous languages. So while he was pursuing his MFA and PhD, he was also developing his career as an application developer. So in today's talk, John will cover cultural representation within technology and how we can practice decolonial computing. So everyone, please join me in welcoming John Corbett.
Hi. Wow. Welcome everybody. John Corbett in Nitsikasun. I am Cree. I'm Métis of Cree and Saulteaux ancestry, mixed with English. My English ancestry is actually from way back in the early fur trade days. One of my ancestors, John Sayre, was one of the very first fur traders in Canada, prior to even Hudson's Bay arriving. And he was always in competition with Hudson's Bay. He started or is a co-founder of Northwest Company, or worked for Northwest Company for many years, along with his children. He married into an Ojibwe tribe very early on in the 1700s, and in order to initiate trade. And my father always said that he wasn't a settler, so not to confuse fur trade with settler, because the fur trade, they were here to make a living. It was a new land, new opportunities. He came here to make a living, to bring that income home to his family in England, and that at the end of his career ultimately retired, go back home. He never intended to stay in Canada, but his offspring did, and they always married back into community. Probably the most famous of my ancestors is Pierre Guillaume Sayre. He was, if you look up the Sayre trial, he was put on trial along with two other men for illegal trading with First Nations by Hudson's Bay. And at that trial, Louis Riel Sr. showed up at the courthouse with 300 armed Métis men, then kind of said to the judge, "Find him guilty." See what happens, right? So there's a little bit of resistance there. He was ultimately found guilty, but the judge decided not to assign any penalties, so he was set free. But that particular court case marked the end of the Hudson's Bay monopoly in Canada. So it was instrumental in turning around the monopolization of the fur trade by the Hudson's Bay Company. So I'm very proud to be a descendant of a disruptor. And that's I guess the pride that I bring with me. He married into a Cree community. So my grandmother was born and raised in Manitoba, in Dauphin, just south of Lake Winnipegosas. My great grandfather was Saulteaux and French. And so my understanding is through our family history that my grandmother spoke Cree and Michif as well as English. My great grandmother would have spoke Cree and Michif, and my great grandfather would have spoke French and Michif. So they communicated through Michif, but because Cree being dominant in matriarchal society, which is my great grandmother, that is my heritage language is Cree. Even though way back at the beginning we started it as Ojibwe, so we're kind of all underneath that umbrella. The Anishinaabe family kind of breaks into these smaller subsets. So today I am presenting my research on Indigenous cultures and programming. So the title of my talk in Cree is AAC Mamit Dane Taman Numikis Gate Dawai Gawin Mamit Dane Chigan Iganagik, which kind of loosely translates as thinking about an artificial brain in the artificial brain. It's another way of saying philosophy. We don't have a word for philosophy in Cree, is what I was trying to get an elder to help me with. How do I say philosophy? It's just, how do we think like Cree? And then the word for computer, the original word that I had was chickenus, which kind of loosely translates as a box of shadows that tells a story with no pen. Taken from the word for typewriter, which is to type a story with no pen, and the word for TV, which is a box that has shadows in it. So they merge those two together, but it's really difficult to say, and I'm sure I'm butchering that pronunciation. So Mamit Dane again is easier, although I still have problems because our words can be very long. They're set up by morphemes that are attached to one another. And it just, it kind of literally means artificial brain. A little bit about the layout of how I'm going to go through today. This is my faux magazine cover. That would have been in 1971 when I was born. I made being an artist, I like to make things visual. And so I thought about this presentation in the form of a magazine because I'm very tangible. I like things that I can touch and things I can read. And I think the art of reading a magazine is slowly finding its way out. Even reading books, I do so much reading now on the computer that not having something tangible to flip through. So I made myself my own magazine cover. So if I had a magazine called Cultural Computing, this is what it would look like. Complete right down to my mail label. So this is just basically, I'm going to go through some of the overview of certain paradigms within computing, and address or talk about things cultural agnostic, cultural neutral, as they apply to computer science or to computing in general. Talk a little bit about what decolonial computing is and ethnocomputing. And then I'm going to break into using my work as an example of how all these things kind of tie together. So to get started with cultural agnostic in computing, this is actually two different ways of looking at computing. One is creating technologies that are easily accessible regardless of what culture you come from, so that it doesn't really matter. They should be intuitive. Another way to look at it is a computer system is considered culture agnostic when it can run on any system or OS, right? So if you have a computer program that you only need to write the code once and it'll execute on multiple systems, that's an idea of being culturally agnostic. It doesn't matter what kind of system it's going to run on. If it has a proper compiler, it should be able to run in Mac or Windows or Linux or whatever operating system you have. So two ways of looking at cultural agnostic within computing. Those are the terms that you would come up with. And the reason I I bring this up is because when I first started looking at decolonizing computing, I wanted to know, first of all, where does it sit within a spectrum of being agnostic or neutral in terms of how it's represented in culture or in our society? Which took me also then to cultural neutral programming or computing. So cultural neutral computing tends to place emphasis on culture and cultural representation, but as an inclusive form for computing practices, right? And so it's not looking to be specific to Western computing practices, Eastern computing practices, or Indigenous computing practices, but computing practices that for the most part have been accepted by a majority of culture. Not to say that it is entirely neutral, but there are less sticking points, shall we say, to its cultural specificity within their design. And it's also mindful of the potential biases that technology can contain. And I have a couple of really good examples coming up. The most important thing here is I highlighted in yellow, which is it's shaped by the values and the perspectives of people, with the emphasis on values, right? So what I value as an Indigenous person versus what is valued in Western culture, probably time for me is the greatest point of concern. Time is a commodity in Western culture, Western society. Time is money, right? So time is automatically commoditized, and we use time as a way to gauge money in exchange. Time in an Indigenous perspective is, you'll hear the term time immemorial, right? Forever. Time doesn't have the same tie to finances and money that it does in Western culture. And so that's that conflict. So that the value on time from an Indigenous perspective versus a Western perspective is a point of concern. See my.
I know, I'm sorry.
Oops, I'm playing with the ball. Here. All right. Anyways, keyboards are not culturally neutral. That's what it says. Keyboard, not culturally neutral. The keyboard, in particular, the QWERTY keyboard, is actually a standard. It is the standard. It's a horrible standard, I think, because it doesn't even represent English properly. The QWERTY keyboard layout is highly inefficient for even English, and it is really dependent upon the corpus that you use, right? So to judge these models of the computed keyboard and how these came about, we look at works written by authors, and we put them into a system that will calculate, in what sequence letters occur, co-occur, how in their frequencies, and then where you place them on the keyboard to minimize the finger distance travel. QWERTY is a really bad example of keyboard layout. It comes, it's a legacy keyboard layout that came from typewriters. Originally, there's some that say that it came because of type bars clashing on the typewriters, and yet that doesn't make any sense because when that was no longer a problem, it still didn't change the fact that they still put those characters on those type bars. You can just switch around the key buttons without having to switch the type bars. So I don't believe in that. There was one theory, though, that the top line of the QWERTY keyboard allowed you to write typewriter, and it was a sales tactic. So that salespeople could go in and go, look how quickly you can write typewriter, because they didn't have to use all 3 rows. They could just use the top row, type the word typewriter, and here's your sales, your sales form. How many do you want? That sounds feasible to me, because now you're giving it to individuals who need to be able to access it quickly, and they themselves are not typists, right? So we're talking 1900s, late 1800s, early 1900s. The other thing that is kind of ignored is who were the first users. The first users were actually Morse code operators at the telegraph office. in order to get their messages put down properly, they had certain codes and certain letters that they would use on the type that they would have to hand write down. So the typewriter was actually rearranged, and there's documents that prove or show that there's telegraph operators that were giving notes to the typewriter manufacturers to say, can you move this key here or this key there? We don't use this key. It's not used in the telegraph. And so it gets in the way, right? It's in the way. And there are some examples of the keyboards actually being switched around. So QWERTY was landed on in the 1920s and then became a standard. It's now controlled by the International Standards, ISO, International Standards Organization. The one thing that I find really interesting is their current standard for multilingual and script keyboard layouts is this one here that says this repertoire is intended to address all characters needed to write all languages using the Latin script, together with standardized Latin transliterations of some major languages using other scripts. So what they're kind of saying is that it doesn't matter what language it is, as long as it can be represented in a Latin character set, the keyboard has no problem addressing that. But they just made you use a Latin character set to represent your language, and that's a problem. And that's one of the things that I'm trying to address. So that moves me forward into talking about cultural computing. And really, this is just more of a how do we use cultural representations in computing, and using cultural representations, whether it's language or imagery, customs, practices, all of these things that relate to cultural identity, and how do we use those as forms in a computing sense. There is this article here that I really like. It's on Zenetic computing. It's all about Eastern knowledge traditions in Buddhism and philosophy, and using those ideas to direct a computer's engagement with the user. And that was kind of the starting point. So when I started looking at culture as using culture as the interface to the computer, right? And it's not necessarily considered by the devices themselves, but the culture of the user as an individual is what should be driving the interaction with the computer. And that ultimately results in decolonial computing. So decolonial computing is just a deconstruction of the computing apparatuses that we have, the technologies that we have. These two quotes here are actually from the Syed Ali article that I've mentioned here. And he opens his article with how can computing be colonial if we live in a post-colonial world? I was actually asked a question similar to this in my master's defense because I talked about computing practices in a post-colonial culture of Canada. And the question that was asked of me is, how do you define colonialism and post-colonialism, and how do you know post-colonial society? That caught me off guard. I was not prepared for that question. I made, I don't want to say it's an assumption, but I'm eager to move forward. When Canada went to First Nations and officially offered the apology and created the TRC, right, the Truth and Reconciliation, they were saying that it was wrong, right, that we need to move forward, but in order to do that, we have to offer this apology first. So there's a formal apology by the federal government. That technically marks the end of a colonialism period. Now, that's not to say that we are now in a post-colonial, state, but we're on the way there because that was kind of the first step. So before that date, I would say we were not in a post-colonial way. We've been using post-colonial in terms of academia long before that happened, right? And it's only really applied in Canada because I don't think the US has gone and given a formal apology to their First Nations communities either. So within Canada, in the Canadian context, we're at a point where we can move forward in a post-colonial context because there is acknowledgement on both sides by First Nations of this of these lands, and the federal government that acknowledges that there was wrong done, and now we move forward, right? And so decolonial computing is about taking some of these ideas that are in computing, the practices that we have, and we're just changing who is it that's doing the computing and where are they located, and what do those actions mean to them as individuals, as users of the computer and the technologies that they are using. In the early 2000s, ethnocomputing kind of came about. It was an extension of another ethnoscience called ethnomathematics. A lot of it was headlined by Ron Eglaff in the US. And Matty Tedre created ethnocomputing as an offset of, or as a subtopic, I guess, out of ethnomathematics. Because it's not moving fast enough, right? We have ethnomathematics. How did the Incas count? There's actually a lot of the Quipu database system. I don't believe we call it a database system, but it's a string of knotted threads. And those knotted threads were calculated, cattle and land and people. They were used to take censuses. They recorded all of this numerical data, similar to the way Chinese abacus is used. And that's a really good example of ethnomathematics, is how were these mathematical constructs used, that are not in a Western context. Another example would be from a Cree perspective, up until probably contact, there weren't that many words that went above 100. There was no need for them. You either had, you had 5 or 20. So they'd use on pictographs and rock paintings, you might see a hand, or you might see a body or a couple bodies. They told mathematical references in drawing by using a hand for 5 or a body for 20. And so you could calculate 45 would be 2 people and a hand, right? So it'd be 45. But there really wasn't any need for numbers above a certain point. So even today, there's a lot of Pacific Islanders that don't have numbers above 20. Anything above 20 is just considered a lot, or a lot, right? So if you have 26 versus 53, same number, it's called a lot. They don't have any need for numbers beyond a certain amount. So when you get into ethnocomputing, how do those mathematical systems apply to the computer if your abstract concept of numeracy isn't supported in the computer? But it also extends into these other components such as sorting, geography, so locating, design, play, and interaction. And what I particularly like is metaphor and relationships. Indigenous cultures are highly integrated in relationships and kinships with objects, with things, with the environment, with the world. It's not just a matter of how are these two things related, but how are they kin, right? How are they related to one another? And I thought I would include a little bit on indigenization here, just as an extension of ethnocomputing. So indigenization is kind of, for me anyways, an interpretation of decolonizing and indigenizing. They kind of go hand in hand, where decolonization comes to dismantle those colonial constructions that are built into our politics, into our technology, into our curriculum, our education systems. We have all of these systems in modern society that still have colonial components to them. So decolonialism or decolonization is about kind of disrupting, and dismantling those, whereas indigenization is introducing and promoting indigenous ways of looking at the world into those systems. And I always recommend reading anything by Glenn Aikenhead. He's a professor emeritus, I think, from the University of Saskatchewan. And he did a lot of work in talking about Indigenous education, Indigenous worldviews within education, curriculum, internal politics within the school systems, how all of those things can be changed or looked at from Indigenous perspectives. He is a very long and he's highly respected in this particular area. And before I get into my final transition into my actual work, I wanted to talk a little bit about cultural appropriation because it's not always what you think it is. And sometimes we do it without even knowing it. And I'm going to give an example of my own, but I'm going to lead it off first of all with an example of Glenn Aikenhead. He gave this example. He says, if you were a math teacher and you're out at an art gallery, you happen to come across a painting of a wonderful landscape with a bunch of birds that are arranged in a very particular order. And you read the artist's abstract or the artist's statement, and it says, these birds represent this particular aspect of my culture and how we relate to the winged creatures within our lives. And so it has a very spiritual message that's attached to this painting. Now that math teacher takes a picture of it and goes to schools and this is a fantastic example of what a tessellation looks like. And so he shows it to his students and he says, look at this amazing tessellation by this Indigenous artist. It's not that he is misrepresenting, Indigenous artist did an amazing job. It's an Indigenous work of art. That's not where the appropriation came in. The appropriation comes in where he applies his understanding of what a tessellation is to what the painting represented. The artist statement clearly said it was spiritual and related to the relationships within her culture, yet he's describing it as a mathematical tessellation. And so he's appropriated the meaning of that painting. So now my own person, I did this and I didn't even realize it. And, I didn't notice it or recognize it. This is years ago, probably 5 or 6 years ago. I was invited to sit at a pipe ceremony, and in Cree culture, pipe ceremonies are generally reserved for females, only women, or if it's special occasions, we do pipe ceremonies for feasts and stuff that might be led by a male elder. But they're highly, highly regarded, very significant to the women in our culture. And so being allowed to sit in on a pipe ceremony, I sit last. So there's surrounded by women and I sit last. So I get the last, I sit beside the elder basically. And I was thinking about these, I'm trying to apply everything I'm learning about my heritage to computing. So I want to represent this as a computer programming language, as I was trying to build at the time. And at the end of the ceremony, I was talking to the elder about how much it felt like a sequential loop, right? Like it was a loop because the pipe would go around. And it's very systematic and move from one stage to the next stage, or the next one person to the next person. And I described it as being I was like a looping algorithm. So I was thinking of computing loops as ceremonial, this kind of pass the feather or pipe ceremony. And that was me applying these Western ideas to something that was sacred. And that's a no-no, right? But I didn't realize it at the time. Now I know I don't use ceremony for loops in my programming language, which we're going to get to right now. This is my Nehiyaw examples, which is at the crux of my research. So this is where it kind of started. When I was doing my master's degree, I wanted to bring my culture, my family heritage back into the family after my grandmother passed. She actually suppressed or self-oppressed her indigeneity. Nobody in the family really knew. We knew my grandparents, they spoke a different language. That's all we could really tell, but only to themselves and only in private. So my dad and my aunts and uncles only ever heard it, never knew what it was, and didn't ask any questions either. It wasn't until the Canadian census was released for the early 1900s that we found my grandmother in the roster, and she lived on a reservation in Dauphin in Manitoba. My dad, I think, and most of my aunts and uncles were all born in Paw, and that whole area, that Treaty 2 territory, is heavily populated with Indigenous, a lot of Indigenous fishermen. My grandfather in the 1940s was assigned to be a liaison between a fishing business in Winnipeg and the fishing communities around Lake Winnipegosis. And so we theorized that my grandfather learned Cree out of the necessity to do his job so he could talk and negotiate with these fishing communities. And that's where he met my grandmother. And then, so that part of the family history, it now all makes sense. But my grandmother, she curled her hair. She went to, she became a Roman Catholic. As far as I know, my great grandparents didn't have any religious affiliation, but in order to, I'm theorizing that my grandfather gave her the opportunity to escape residential school. And so my aunts and uncles and my father were never taken. And they all moved to a farmstead in northern Alberta, kind of farther away from where residential schools were starting to spring up. Although they did start to grow in Alberta, she made it out, I guess I'll say, safely. So I wanted to bring some of that heritage that would have been lost, or that it was lost when my grandmother passed. And so I thought, what better way than to represent my children in a traditional craft, which is beadwork, so Métis beadwork. Portraiture isn't really a beadwork thing. It's not a Métis cultural practice, but me being an artist, I thought this was a great way to represent the tradition of Métis beadwork and passing it on to my children. I found this very tedious and I didn't like it. And a lot of decision making. What color bead do I put? Where do I put it? What comes next? So I wrote a computer program to do that for me. So I didn't have to do it. And then I just, beaded it as a pattern. So this image here on your right is my son, Lucas. This is the generative pattern maker that I created. It's being projected onto a cowhide here. But I took that image and I manually or physically beaded it to deerskin, which is this item on the left. A couple of things about beadwork. When I was beading, I learned that when the thread ends, you don't just get a new piece of thread and continue your beadwork. You tie that thread to the previous piece of thread. That way the thread is continuous. So the thread has to exist from beginning to end without a break. It's very difficult to do in one big long thread, so you just tie a new thread to it. So long as that thread is continually connected, you get the idea. If you see the back, the detail on the back, my stitching goes from left to right, and then it drops, and then it goes from right to left, and then it drops down, and left to right, and back and forth in this kind of serpentine. My original code for this is right here, kind of in a pseudocode. When I was beating it, and I realized, hey, my program doesn't do this. My program goes left to right, next row, left to right, next row, left to right. And I want to change my program to reflect how I do it. I want it to go left to right, and then right to left, and then left to right. So programmatically, it turned into this. So it's a lot more verbose. Doesn't care about proficiency. It's a little bit more instructional heavy for the computer. This would be a better way. And this is where that whole concept of better. Is it better? From a cultural perspective, this isn't the way to do it. That's the way to do it, because that's a reflection of how I would do it physically. And then I took a step further. I didn't like the idea of also making it on a grid. That's a Western construction, having everything in these rows and columns. These spiral and circular patterns are a lot more representative of our culture. Spiral in particular, circles are circles, but spirals are about building upon, as you go around. So as every season, every year has 4 seasons, but those 4 seasons are never the same seasons. They're always a season, it's another year. So we've grown, we've aged a year, And the seasons, we still have 4 seasons, it's cyclical, but it's an advancement of those seasons. So, you know, this spring is not going to be the same as next spring, and it's not the same as last spring. So building in those ideas into my beadwork. And I used actually a Western context here of the eye being the gateway to the soul. So I started my beadwork at the eye. I did try other origin points. And this turned into an animation. And so I'll just continue to talk. This was, when I completed this, I got an email from somebody that wanted to put this into an exhibition. I'm like, yeah, sure, I'm an artist. Every exhibition is going to help. And they go, great, we'll send you a contract in a couple weeks. I didn't know who it was. I just knew that they wanted to put an exhibition. Find out that it was the Smithsonian in New York. They wanted to put this in the exhibition, and they wanted this animated version. So this animated version was part of my MFA thesis project. And it represents the 4 generations, or as every bead that's being placed develops you. So every bead is kind of a day in your life. And as the beads, you know, start to accumulate, your identity grows and grows and grows. But what happens at the end of your life is you start to pass, or throughout your life, you're passing on that knowledge. And so what happens at the end, which was actually the beginning, is there was an unbeating for the eye. There's a series of unbeatings. So it started with an empty space, and then beating the next generation happens in its place. So it passes on from my grandmother to my father, to myself, to my son, and then loops back to my grandmother. And it's about that transgenerational knowledge that's being passed from one generation to another in sequence. So as each bead is placed, it continues on. And there are a total between all 4 portraits, 34,728 beads, which is 1 bead for every day of my grandmother's life. So that's lots of metaphor that's put into that. I thought while I was doing that, the only other thing that would make that even better is if I could program it in my language. And that's where I started to run into a lot of problems. The IDEs didn't support Cree Slavics. We don't have punctuation. I found out in our language, we have a period. That's it. We don't have any other punctuation. Problem with numbers and numeracy is different. For example, the number 9, we have a word for 9. It doesn't mean 9, it means almost 10, because there is no word for 9. So we use the word almost 10. So in English, you can count 1 to 8. That's not a problem. Almost 10, 10. There is no number for 9, even though we use a word that just means almost 10. And talking about variables, loops, and conditionals, where I really came to a problem, I guess, obstacle. So this is just a couple of screenshots. The processing 3.5 IDE from 2019. You can see by all these little square boxes. That's what Cree Slavics look like in their IDE. Visual Studio currently supports, you can tell it what font to use. And so I can give it a font and it will put them in appropriately. And I think the new processing 4 also allows you to specify a font. However, there are no monospaced Slavic fonts for Cree. I made my own. So what I wanted to do with my own programming language was something like this. I wanted it to be symbolic of the culture, and I wanted it to be a way of visually representing a story through telling story. So I wanted the code to be story, or I wanted to use the story as code. And so this is the introduction. It's called Wazagachuk Goes for a Stroll, or Wazagachuk Walks is literally how it is in the Cree title. And it's the intro to a longer story called Wazagachuk Meets the Three Chickadees. So this was the very first output from my programming language, and it's just an animated crow that or raven that walks along a path in a forest. But to get to that, I had to undo kind of everything I knew about programming. So this is my current IDE. You'll see on the left is a whole bunch of Cree syllabics. This is an actual story. This is the story of Ozagachuk and the three chickadees. I found that a lot of these stories are orally told through our elders, and we want to respect how they're told. So I didn't want to actually disrupt this and use that as the code. What I did was I created a coding window, and I used these little feathers. So there's a feather at the top there. This other little pin here, the yellow pin, is a feather word. So if you click on that, it opens up a coding window on the side where I can program and code. And it inserts at that part that changes the animation or moves it along in the story. And that was a better way of controlling the story. This also comes from an audio recording. And so when does it actually run those or execute those? It executes those at the timestamp in the audio. So it just runs a loop until it hits the timestamp in the audio, and then it changes the animation of whatever I put into the coding window. But to get to that point, I had to rethink variables, loops, and conditionals. And I also wanted to leverage the language a little bit. So actually, this part is a little bit, I'm going to gloss over this. By reframing, what do I mean by relearning, I guess, or undoing my Western idea of programming, is I met a programmer from a Hawaiian programming group that were translating C# into Hawaiian. The problem that they had was there is no, in their conditional statement, if X equals Y, then Z, right? They don't have that if then statement. It doesn't make any sense. It doesn't make any sense in its syntax, so they don't have a way of representing that. So they had to come up with another way of representing an if conditional statement. And they found that they talked with elders, and the elder said, can we use a river? Because really what you're doing is you're branching off an idea. You're going down the river and you're coming to a point where you could take path A or path B. That sounds like a river. And we do that with, to grow taro root in Hawaii, they'll take a branch off of the river, make a little area to grow taro root, and then they merge that waterway back in to the main water stream. So that rejoining of the water is actually really important. Water is also very important to Cree culture, and water, rivers in particular, and moving water is extremely important. So I adopted that same kind of rationale. So I created loops, or sorry, my conditional statements are all based on rivers, and a river breaks into a smaller river. So the river word P can turn into Sapisis, and you'll have multiple Sapisis. Sapisis is just a small river or a creek, right? So you have a main river, that'll be your main idea, and it branches into these smaller branches. At the end, you would say you have to give it a command to rejoin the river, because programmatically, I can't just end. The waterways don't just end. They end in a pool, usually at the end of a lake or the ocean. A creek or a river rarely just ends on its own. And that got me thinking that this cultural metaphor application was really, I think, the way to go without disrupting how the stories are told and the stories I want to represent by the elders and how they're portrayed in the computer through animation. So I went back and looked at variables, and I just thought about what a variable was. For me, a variable is just a container. It's just a thing that holds another thing. So in the context of the computer screen, I made a screen variable that I can define. There's a forest, right? So the screen contains a forest, and it animates from left to right or right to left. That forest contains Ozagachuk. Ozagachuk exists at a certain point inside that container. And that container was a really great way, I think, of looking at it. We have all kinds of containers in Cree culture. The one I settled on for coding, taking my lesson from appropriating, was a berry bag. I was originally thinking of using our medicine bundle, but that is a sacred object that has another context to it, and I didn't want to use that. But A berry bag, or a bag that we use for picking berries or medicines, is a multifunctional bag. We use it for all kinds of carrying. And so I use a berry bag as a variable container. So I describe something as a berry bag, give it a name, that becomes my variable. And finally, for loops, I actually got the loops from a dream I had. It was after a class. I was in a language class, and my instructor was talking about how we gauge our age. So in Cree culture, especially in northern Alberta, we describe our eggs as how many our age as how many winters you've lived. So I'm X winters old, right? And the reason for that is winters are harsh in Canada, and so we have making it through winter means that you are resilient and you made it through. You're strong, and so it's a particularly highly regarded achievement to make it through winter, as harsh as they can be in Canada. And it's a lot similar in the U.S. Go south in the U.S. where the summers can get really hot. They typically gauge their age by how many summers old. Right? So same idea, but I use Papona for winters. Now there's a couple concepts with winters. Is we can refer to last winter and next winter. There are separate words for those. So within the context of my programming language, I made that available. They typically only hold numeric data. So for X equals 1 to 100, for example, but it would be for the next 50 winters, run this sequence of commands. Those 50 winters, I can calculate previous winter and the next winter, so I can refer to those values within the context of that loop without actually going and calculating it within the loop. I can refer to those separately. And finally, leveraging language. This is where I wanted to introduce the ceremony. The ceremony is still really, really, I think, important. But I found the perfect place for it, and that's at the very beginning. So in Cree culture, for those of you that don't know what a smudge is just a personal ceremony. We usually light sweetgrass or sage or some other medicinal herb like cedar. Tobacco is usually used, but that's usually in the pipe ceremony, that's exclusively used for that. But we do that to create a little bit of smoke, and then we take that smoke and we kind of wash it over ourselves, making sure that we bring it to our ears so we can hear properly, our eyes so that we can be attentive, to our throat so that we can speak truthfully, to our hearts so that we come in with the right frame of mind, and then our entire body so that you're prepared. Right? And, that function is actually something that happens in the computer as well. We clean out our cache system, memory, we clear the screen. You might you stop and start the audio, right? It's the same physical or digital versions of the physical representations of that smudge. And so the smudge is actually the way of telling a program to run. Whereas in a Western context where you might write a program and then type the word run to execute it, the program already exists, and we type the word run by calling the smudge. The smudge just does all that preparation for us and then starts executing statements. So it has to be the first line in my programming language. If you're missing it, it won't run. It has to have a smudge there to digitally represent that practice of making sure the computer is ready to accept the extra lines, the next lines of code. The last part was morphemes as functions. So morphemes are just independent. The best example I can give is the word for hippopotamus. I can't pronounce the word for hippopotamus because it's too long and it's very complex, but it translates as big tooth, big nose, thick skin, big butt pig that swims underwater. You can mix those around and go thick skin first, or big butt first, or the pig that swims underwater first. It doesn't matter. All of those components are there. And so they all mean the same thing. And so I want to be able to do that within my programming language. And so where I would have a variable, say a Tim is the word for dog. And let's say it holds a value, a numeric value like an integer. And I just want to take, I'm minusing 1. So a Tim equals a Tim minus 1. We use a diminutive, so atymosis. we just add an osis to the end. And Mr. Hit down here, Mr. Hit makes it big. So if I said Mr. Tim would be a Tim equals a Tim plus one. Now, morphemically within our language, I can actually have both of those together. So I could have Mr. Timosis. Even though a Tim means dog, Mr. Tim, depending on context, usually means your horse. And so a Mr. Timosis, where a Timosis would be a puppy, small dog, Mr. Timosis is a small horse or pony. In my programming language, if you put in Mr. Timosis and you had an integer value for a Tim, you would actually be no different than writing a Tim equals a Tim plus one minus one. So it adds and takes away one from that. Now that I had all the language stuff sorted out, I had a problem with the hardware because I started critiquing everything within the hardware. And I already talked about the problem with QWERTY. And I wanted to apply all of these, other ideas in Nehayahu teaching. I wanted to be able to get those syllabics into the computer without using Western style keyboard. So I decided to make my own keyboard. This was a practice sheet that I used. So I attended the University of Blue Quills in St. Paul in Alberta. And it's an old residential school, the Blue Quills residential school that the First Nations actually took over. Blue Quills First Nation took it over, turned it into a university. And it was, I actually believe they were the first university, indigenously run, owned and operated university in Canada to provide graduate degrees. So they have a master's and a PhD program. But this was one of the ways of learning Slavic. Slavics have 4 vowels, and each Slavic has 4 orientations that they're either reflected or rotated. And they go in these 8 directions. So I wanted to see if I could build a keyboard kind of using that idea. There are some prototypes before this, but this is ultimately what I ended up with. What happened was when I laid these out using a keyboard layout, using actual square keys that we would normally have for a regular keyboard, there's all this dead space in here, right? There's all this empty space. And I didn't know what to do with that extra space. So I thought, well, if I rounded off the keys a little bit, and that would help close the space. So instead of the key being square, if I just elongated it a little bit, it would close up some of the space. Then I'm like, I still have a lot of empty space in here. So long as the syllabics exist within that direction, because the direction is important, I can put this key beside, one of these other keys, and I can kind of close it up. So this layout here that's on the right is I guess the final version. When I decided that this is actually how it looks. And when I put it in this orientation, obviously it's circular. And is reminiscent of a drum. We use the drum or the floor plan of a teepee, Migawapp. The lodge floor is what it reminds me of. So now that I had my keys sorted out, I needed to actually make them because keys like that don't exist. So I had to make the keys. So I put them into a CAD program. And when I was chamfering these edges, I also don't know anything about 3D design, so I had to learn all of this from YouTube. But I put in these seams here just to give it some visual structure. When I counted them, there were 12. And I'm like, oh, if only there was 13, because then I could use the 13 pole teachings of the TP. So what I did is I trisected the back. I just took out the center and I added, I split it into 2. This way I have 13 poles. Why this is important is because on top of each one of these keys, obviously, is going to sit the Slavic. And the Slavic translation into English means spirit marker. So our written language is actually spirit markers. That's what they're called. And they're sacred in that regard. And so the 13 teachings of the teepee support the sacredness of the spirit marker. So if the language is sitting on top of each of these, it's like it's at the top of the teepee close to heaven. And those poles are there to metaphorically. Now, when you actually print them out, because they're so small, or the keys are only like this big, You don't actually see these seams, but I know they're there because I put them in the design. So to me, it's important that they go into the design. Which leads me to the PCB design. So this is just what a traditional keyboard kind of looks like in a PCB. This is the top part of the rendering for my PCB. This is version 4, I believe. Now up to version 6, because I now have a top and bottom. But the importance here were the traces. Because my keyboard's round, I wanted my traces to be round. So again, I'm not an electrical engineer either. I learned this through YouTube, making my own keyboard design. And an elder had told me that when you enter a teepee, you always enter through the east door. So the door to a teepee almost always faces east. The reason for that is the sun is considered the source of all knowledge. And so you want the sun to come in through the door. When you sit in ceremony, the elder who's leading ceremony always sits facing south. And so I put my microprocessor here, but I say to the east. This is one of those things that you have to get around. People would say, oh, but it's on the west side of the board, but it's not. So if you're sitting in ceremony and you're facing south, so if I'm sitting in the middle here or sitting on the edge facing south, right, this makes this east, that side's west, and this is north down here at the bottom. So our orientation is also dependent upon cultural teaching. And when you enter that teepee, you enter through the east and you walk clockwise or according to your culture, because Ojibwe, I think Saulteaux, Dene will walk counterclockwise. Most Cree walk clockwise. The reason for this is people from different cultures, if you all walked into a teepee or into a lodge and you all walked in the same direction, you'd never meet anybody. So walking in and being able to go according to your own culture, you cross paths, you get to greet other individuals, you get to meet them on their journey before you sit down or take your place within the lodge. Same thing happens on my board. So I had all my positive electron flow attached to my even nodes on my microprocessor, and all the negative going to the odd. Right? The electron flow went to the odd or even according to which way I wanted it to travel along the board. And that's what they look like when they were finally assembled. Now this one is hand painted because I'm an artist and I like the visual representation, but this is when I was assembling the first one, the bear, I kind of like, each of these kind of feels like a tortoiseshell segment. So I created this one here. This is my Turtle Island keyboard. This is the one I actually use personally at home. And these are actually the numerics that we would use in Cree. So there's how it's described to me is 1 stick, 2 stick, 3 sticks arranged in the syllabic, 4 sticks. So it's just like Roman numerals until you get to 10. 10 is here. This is 100 and this is 1,000. And so we only count up to 1,000 in our numeracy. So if you wanted 1,000,000, it's 1,000 thousands. But that's how they're represented. And of course, I had to make a soft version so that I can use it on my phone or on the web. One advantage to this is I have this button right here called SRO. So standard Roman orthography. If I wanted to convert my syllabics into a Romanized form so that I could read them, I could just click that button and it'll change all of the text on all my buttons into the Roman orthography version. And that's to help learners, if they're just learning and they don't know all the syllabics yet, they can flick it back and forth and see it. I can't do that on my keyboard because those are permanent. But I also found that when I was using that, I have 2 keyboards and that occupies a lot of space on my desk. I thought, wouldn't it be great if I could just integrate them? And so this is currently in development. I have the PCBs, my PCB maker. This one was more complex than my other one. And so I found a guy that can do this for me now. Having gone through it myself, hours of trying to figure out how to do traces and how to get them printed properly. found a guy that can do that for me. So I'm actually making my own standard QWERTY style keyboard so that I can jump back and forth between English and Cree. Which finally brings me to my Indigenous computing framework. So after all of that, what I realized was I was questioning everything I did, everything I touched that had to do with the computer. I was trying to figure out, is this Indigenous? Can it be Indigenous? And if it isn't, why? And how do I make it that way? And so also in my master's degree, the title of my master's thesis actually was called Indigitalized Métis Métis beadwork in contemporary artistic production. So I created this. I didn't create, actually, I shouldn't say that. I didn't create the word. One of my advisors said, I wonder if there's a way that you could make Indigenous and digital and just smash the two together. And so indigitalization is what it ended up becoming. So I have to give the credit to him. So what is a computing framework? It's just a guide that dictates, how we build our technologies, how we build our applications. It's just that framework, right? It's and it can be physical or abstract or conceptual. So that's what in general, what a computing framework is. But an Indigenous computing framework is the same idea, but it uses or puts forth Indigenous theory and privileges Indigenous theory above Western computing concepts. And where returning to that idea of value, what is valued within the culture. So in Indigenous culture, time is not valued the way it is in Western culture. And so I don't care how inefficient my code is. The fact that it represents how I would culturally perform something is more important than the so-called efficiency. Yes, the computer will run faster in the other context, but that is not how you would do it if you're working from an Indigenous perspective. And I wanted to apply teachings within the computer based on how I learned, right? So Indigenous pedagogy as part of the informed structure of computing and of that computing framework is what ultimately I tried to come across and tried to find examples of. And I think the next slide is my as indigitalization. So one of the things that Nehiyaw culture actually, and almost all First Nations that I've met, all Indigenous people that I've met always claim or always say that their language is ceremony. It's our language is spirit markings, right? If it's written. And so if that language is considered ceremony, then the act of programming is a ceremony, right? Because I'm using these spiritual markings inside the computer, has to be ceremony because it's my language. And by that extension, we also say our language is medicine. So because we're using our language, we are developing our Indigenous identities. And this is true to almost all Indigenous people in the world. Their culture and their identities are so much integrated to their language that it's medicinal in order to use it. And so by that extension, computer work programming is medicinal. And this should be my example. Individualization is the braiding of worldviews. So when I talked about earlier with decolonization and indigenization, decolonization is about that deconstruction. Then you have indigenization. So I just take that deconstruction of the Western framework. I find ways to indigenize it, and then I reconstruct it, right? I put it back together. I'm not getting rid of necessarily Western concepts. I'm just trying to find the best way to integrate the two, allowing both to act independently and be their own thing. So the Western ideas and the Western concepts are not turned into an Indigenous concept, nor is the Indigenous concept turned into a Western concept. They coexist, right, together, and they're braided together without having to be converted from one state into another. And I came across this on Monday. Elder Duke Redbird gave a talk, and somebody had showed me this slide. So he's giving a speech, and he created something called elder rhythms, which is just an elder's version of an algorithm, and which based on the discussion that I heard, is just an algorithmic expression of elder knowledge. This is the kind of individualization I think that the Indigenous computing framework really needs, is support from the elder community, which is very, very tough because elders are often resistant to technologies because they are so ingrained with Western ways of doing that they disrupt the community and the Indigenous practices that happened in community. And I was very excited to see this because I think he has that foresight to see how important computing is going to be in the future. And if elders get on board and help grow this idea of elder rhythms, then Indigenous computing is going to be more pronounced than what I've ever done to it. So I think that's, and this is what it would look like visually. Basically taking, in my case, my Nehiyaw epistemologies and ontologies, and it has to integrate all of these things, whether it's software or hardware, the theoretical, the conceptual, the physical, all of those things combined together are included in this framework. And I should have mentioned this earlier. Nehiyaw literally translates as the four body or four spirit people. So Cree is actually a French word, le Cree, I think is how it's pronounced, but it's when the French came to the lands of the Cree people, and all of the Cree were like, we always go, we have a way of expressing welcome, and that to them, oh, they're crying. So we are the crying people, the ones that yell and chant and happiness. So it's a positive thing, but it doesn't apply to all Cree because there are Nehiyaw are the four body people, and then there's Nitowi, which are a different type of people. Anishinaabe and Ojibwe, they all have what they refer to themselves as. So Nehiyaw is four body or four spirit, and those four spirits are the physical, emotional, psychological, intellectual, spiritual, intellectual, physical, and emotional. So the four spirits, and all of those four spirits are included in this framework. You'll also notice that I didn't use their traditional medicine wheel to describe those four things. Not all communities use it. We use it, but in my own perspective, you have to understand the teachings that go into a medicine wheel in order to use it. I don't think I'm that prepared or that ingrained to understand how to apply those. I think only elders should be creating those types of objects. This was my alternative, which looks way more complex. And that's it. That's the end of my talk. So my research has a lot of goals that didn't actually start out. My goal, write a computer programming language. That's what I wanted to do. I did that, but I also, my advisors joke that I wrote 3 dissertations, not one, because all of these are in my dissertation. But they all, I realized it has to be holistic. I have to account for all of these points where my culture touches that technology in order to understand what it is that it's going to do. Right? So thank you so much. We also say Kinanas Gomitin or Kinanas Gomptin, which means I am very grateful. Thank you for listening.
Thank you so much, John. Well, let's open up to the room for any questions or comments.
John, thank you very much. Such an amazing presentation and research. And I personally connect to it on a personal speaking about rethinking computing in relation to cultural values and the way we perceive things differently in each culture. I'm curious, how do you envision this kind of practice being used in a community? Especially like, for example, the programming language and the issues that it creates in regards to collaborating with collaboration in general. And do you see it as a form of localization of computing? Or because I totally see the values that it creates for someone who thinks differently, who perceives things like conditionals differently, and approaches solving problems differently within that culture. And if you take it away and give it an if then it's a different approach, and you are not the strongest anymore. Thinking in that framework, how do you see that using in the?
I have a couple different answers to that, because I see ultimately at the end, when I reflect on all of the changes that I had to go through to rethink, what are the conditional statements, functions and methods, classes, all these programmatic terms that I use. So the story that I always use is the first day of language class. I go in and I'm all like excited to learn Cree, and I sit down and the elders are like, well, let's just start with what words do you, the class. So my class, by the way, my cohort, the youngest person I think was 26, and the rest of us were all over 40 or over 45 even. So we're a lot of, I'd say, older people learning, or trying to reconnect with the language. And so our elder asked, what words do you want to use? I'm like, oh, what's the word for computer? And that's when the elder goes, you really have a word for computer? And I am in deep trouble. There's no word for computer. That means there's no word for network. There's no word for database. There's no word for, these programming concepts like conditionals and stuff. And that's where I had that. My initial setback was, oh no, now what am I going to do? Right? I can't, all of these ideas I had to create this language. I thought it would be a simple word mapping, get the Cree word for it, replace it, into an English framework. It didn't happen. And I had to rethink, and it took me months. It actually came in a dream where an elder said, I was in my dorm, I went to bed, and that Wazagi Chuck Goes for a Stroll image is what was playing on the wall. And the elder looked at me and said, that's what you're going to build. But he never elaborated on what that was, just said, that's what you're going to build. But I didn't know what, you mean the thing on the wall? I didn't know what that was, right? So the value that I think reframing computing concepts, doesn't matter what culture you come from, if you can think of it in terms of your own cultural identity. And so I've done a couple workshops now with youth where instead of giving them the computational structure, I said, think of things that, like a basket or a barrel or something that can hold stuff. A car can hold people, right? It's a container. So think of containers. What kind of containers can you think of? One of the best containers that they came up with was body. Body is a container for bones and and veins and arteries and a nervous system, eyes. Like it has a whole bunch of stuff in it. And then I said, give me an example of something that branches or goes off in different directions that spiders out. So they had typical things like trees, tree roots, roadways, all kinds of different paths and stuff. Nervous system and the venous system, or the veins and stuff in the body, that also came up. And then that last one of looping, age came up, and circulatory system came up within that. Like, isn't it weird that all three of these concepts had something to do with the body? Some group out of the 30 students that were in it, every single one of these ideas revolved around some systemic thing in the body. So then I said, well, you just wrote your own computer language, right? You have now met your variables for containers, your conditional statements, or your branching systems, nervous system, or your veins, and connective tissues, and aging as loops. All of these things that you've embodied as an individual, as a person, just turned yourself into a programming language. And they were like, oh, this is amazing. And they understood, right? Because they could personalize it. And so I think by reframing computing context, not giving them what is currently, at the outset, the programming structures, because I think they get I'm not a computer programmer. That's usually what you get. It's just like artist. I can't draw or I can't paint, but maybe it's because you don't have an interest in it, or it's never been presented to you in a way that draws your attention or makes you excited about it. So if you take away the context that we're talking about computers and just give them a scenario, and then they fill it in, and then you give them the context and say you've just done this, and that's what a computer system does or is. They were like, I totally can be. I understand now. I can be a programmer. I understand how that can work. I actually had older people that are like, I don't know anything about computers. At the end, they're like, you made it sound so easy. Like I can just go and learn how to be a computer programmer. It's that simple. Well, it is that simple. I mean, that's. So I see that as being beneficial, and I think creating these alternatives in how we look at computing practices and technology are opportunities to explore in cultural contexts that are new and unique and offer new opportunities, different ways of thinking. And so I used another example on my mother's side, primarily Ukrainian, and so I took the idea of a Pisanki Easter egg, Ukrainian Easter egg, and how that one Easter egg has all these attributes as well. So thinking of an Easter egg as a programming language has these components that I would call or need to use in a functional programming language that has variables, loops, and conditionals. I don't know if that answers your question entirely, but
yeah, somehow. Do you see this such programming languages tailored to specific cultural aspects being used actively in the community by at least as a base for grasping the concepts of computing? How do you envision that practically?
From an Indigenous perspective, that is one thing I didn't mention. It's very difficult because, like I had mentioned, elders are typically resistant to technology in general. But you need elders and community support in order to integrate these things. So I can't make my programming language, or I shouldn't make my programming language. I intended it to be open source and available to everybody, but I didn't run it by my elder to say, is it okay if I use winter as a looping, I've talked to enough people in the community that's fine. Obviously the pipe ceremony, off limits, don't want to use that. So I've learned those lessons, but I still need that approval from the elders, the ones that hold the community knowledge to accept it. Whether they like it or they don't like it, they have to see the benefit to the community. And that is the challenge is putting it into a perspective that they understand and see the value as it applies to the members of their community. And that's the biggest thing, or the biggest hurdle to overcome, in my perspective. As it applies to other cultures, again, because culture is so tied to community, having community members involved in that development, for most of this was just me, going back and forth to community, taking what I learned and then trying to apply that knowledge. It's a very tedious process. And because my previous knowledge of computing, goes back 40 years, they don't have that knowledge. So I'm trying to teach them what I know to get them to understand that the knowledge and culture teachings that I'm getting are valuable in this context. That's a challenge, but because of the way I've framed it and I've shown how I have applied these cultural teachings, like the 13-pole TP teachings in design of the keycap, and explain to them how that's significant and why I used it the way I did. I didn't get in trouble for it. We'll put it that way, right? So not yet anyway, I don't know. But I still have to work with community constantly to get this to, and that's the biggest challenge. And I absolutely think that programming in or creating another language or programming language in another language. Ramzi Nasser does this with Kalb, as Arabic programming language. It's not the first Arabic programming language, there's been others, but he's usually described as being the first one. But that's because his conceptual framework for Kalb draws on those cultural teachings and the fact that Arabic is written from right to left. So your programming instructions in terms of your translation machine have to read it from right to left, right in the code. Except when you get to a string that's in English, so it reads right to left, then left to right inside of the string if the string is contained in English, and then right to left again, right? So you have these other challenges because systems are designed in that Western format of left to right reading code. So there are a lot of challenges, but I definitely think if there's enough support from the community, the whole idea is that it promotes the language, so it revitalizes the language. It makes youth excited about using their language in a modern context that's relevant, not only to the culture that they've been brought up in, but in a general societal context as well, because it's applicable to their MacBook or their Windows machine. They can run the code in their language on those machines, and it runs and it works. We can also use it for encoding. So the fact that the original oral story is an audio file, which I can encrypt, but I can also the transcription of it as code is now encoded as the programming source code. So when it's compiled, that could just get added in as comment, but it's now part of the code. And so there's a whole bunch of symbolics that get tied into it, but I think that's where extended value ends up in the community. But that's because it's unseen, convincing the elders in the community that that's important. This is part of the challenge, but I definitely 100% see it as beneficial. Otherwise, I wouldn't be doing what I'm doing. Right? So.
Yeah, well, I have some questions. Very interesting. I was trying to think about other examples of decolonial computing from other colonial or colonized perspectives. I'm wondering, are there some that you have looked to? Are there other examples, or have is this one of the first kind of conceptual working through of decolonial computing? I mean, you referenced some articles earlier, but
so decolonial computing as a subject has been around 10 or 15 years, I think, where you actually, if you did a Google Scholar search for decolonial computing, it kind of started in the late 90s, early 2000s. But there have been mentions of, I guess, colonial underpinnings of computing that go back to the 50s and 60s. I don't know if there hasn't been any that otherwise I'm sure I would have referenced it, collected examples of computing, decolonial computing. A lot of it has to do with language, where computing languages, programming languages, there's a few thousand, 4,000 or 5,000 computer languages, 80% of which are developed on English or use English as their source. Ramzi Nasser said that even in his Kalb programming language, it's a success in terms of being a programming language, but it's still ultimately restricted because it can't bring in external libraries because those were all written in English. And so it will never be exclusively Arabic. It still has a heavy reliance on English because it's got to reference if he wants to use an API or a calendar or a widget from some other application that was probably written in English. And so he's got to rely on these other English systems to incorporate. So in terms of decolonial computing and promoting the cultural aspect, I already accepted that that based on his experience, that's the same thing that's going to happen with me. So mine's a transpiler. So I convert all of my Cree into C# code. That's compiled, right? So I'm doing that English translations as well. And there are some constructions that I just can't get away from. But what it did do is made me rethink how the language operates as a utility. So the way the morphemes are constructed and the way they are stacked together in word segments. That was new and novel. I've never seen that done before in a computer programming language. And so you could have just used, there's a really esoteric programming language called Piet, which uses colored blocks. It's based on Piet Mondrian paintings. So they ultimately, the program ends up looking like a Mondrian painting. There's even one it's called, I think Mondrian Squared, which was a program of, so it looks like a Piet Mondrian painting that creates a graphic output of a Piet Mondrian painting. So very meta, right? But it's ultimately, it's not programmed with language, with language in the sense of English. It's a machine language translation that happens in the background based on color and square placement within a grid, where it goes back and forth based on the color and the position in its loop. So yeah, back to the, I guess, decolonial computing though, still very much in its infancy. And I had a hard time finding computing philosophies that were not entrenched in some sort of decolonial, even decolonial computing has colonial structures to it. I've given similar talks of this presentation. I always change the order in which things happen because a lot of these things happen at the same time. And some happened in relation to others where I presented the outcome first and then told you what happened that led to that particular outcome. Because again, time doesn't happen in a sequential logic format. And I've even taken, I'm reading a book right now by Heinrich Paz. It just came out last month. He's a theoretical physicist that was talking about ancient Greek monism as potentially a way to progress physics and the understanding of entanglement and string theory, where he's relating time and space as outputs, just like physical matter and antimatter. If you go back to the Big Bang and everything is in, is one thing, then everything is everything is related to one another. So the an atom on a planet that's 300 billion miles away is somehow tied intrinsically to that butterfly in Australia that's flapping its wings, that's related to the monsoon that's happening on the East Coast, right? So you talk about butterfly effect on a cosmological level, that's what he's suggesting, and yet those concepts are indigenous and have been for tens of thousands of years. The idea that everything is ultimately related is a very deep indigenous thought process and worldview. And so I just find it's rather ironic that modern day physics are starting to realize that. So, yeah, decolonial computing is in its infancy, but I think the more individuals like myself that engage in trying to put into new context and create frameworks, that's the other thing. That's the challenge is no one's thought about it to the level of creating a new framework. Rethinking computer philosophy is ultimately, breaking down the computing philosophy is in the colonial construction. So breaking that apart and finding out where those commonality and cultural things can fit in, where it's at.
Thank you.
Thank you.
Well, we probably have time for one more question or comment. Are any? Yes.
Yeah, so related to you just said, we can go back in this, as I understand, way back to rethinking the very idea of programming or just rethinking computing.
Yeah.
It's like, would it be the same or would we whisper into something? And I'm not trying to make any examples here, but just rethinking it totally. What do you think, like, and now on the other end of the spectrum, right now, you can think of scenarios like having things like ChatGPT describing things in your natural language if it was inclusive of all languages, which is not, and there are many bias issues in that too. But assuming that it was, you could describe things in your natural language without going back and rethinking everything and having it. Do you see that also as a viable, acceptable decolonial computing approach?
I think I do. I've thought about or theorized what would computing be like if Western academia or Western knowledge production didn't start to segment teaching. So if you go back to Da Vinci, who did science and art, right, and mathematics, he was well versed in all of those things because he looked at the systems as wholes. He didn't look at them. This is just mathematics, and this is just physics, and this is just writing, and this is just art and painting. All of those things were connected. Right? And somewhere along the line in Western history, we started breaking those into smaller and smaller subjects. So what would computing look like? And I wrote a paper in 2013 that described the pixel as being ancient, 3,200 years old, if not older. But in terms of recorded history, 3,200 BC, when we first started recording constellations. So constellations, if you think of the imagery on our computer is just a series of lighted, dots on a surface that we interpret. So we have a way of our brains understanding what all of these lights mean. That's why we named our constellations after animals, because they look like shapes in the sky. So they're illuminated points of light that, when collected together, formulate an image. We've been doing this for 6,000 years or longer, just in recorded history, 6,000 years. And so our earliest computers were constellations. So physical computing was handled by astrology and astronomy. And if our computational lineage starts there and had built up, and we got rid of certain constructs like commodity and putting value in terms of things that can be traded, commerce. If computing could evolve independent of commerce, I think it would have turned out a lot different, and I think it would be a lot more inclusive. I don't think that English would be as impactful as it is in computer programming languages today, as it is, if there was a global development that happened. Ultimately, I think it was largely driven by industrial revolution. So what we now have as our first world country economies, a large majority of those are English speaking. That's why we have English as a dominant language. And yet, what was that? I think it's 33% of the world speaks English. Right, and a large majority of that is as a second language, and yet it's the one that is favored above all else. Right? Mandarin, Chinese, and some Indian languages are the ones that are spoken most in terms of quantity of speakers. English is far, far down that list, and yet it's kind of the language that drives the world.
Well, John, thank you so much for sharing your work with us today, and we're so excited that you joined us here at CIAT. Please join me in thanking John for his talk today.